Hello and welcome to tonight's Spaceflight Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we embark on an extraordinary journey to the Moon. Over the next 90 minutes, you will experience the 3-day transit from Earth's orbit to lunar orbit, learning about Apollo missions, orbital mechanics, and the brave astronauts who first traveled this path. So settle into your most comfortable position, close your eyes, and prepare to leave Earth behind. Take a deep breath with me now as we begin this lunar journey. Inhale slowly for 4 counts. 1, 2, 3, 4. Hold gently. Exhale for 6 counts, releasing all tension flowing into this moment of departure. You are floating in Earth orbit 17,500 miles per hour, preparing for Trans-Lunar Injection, the burn that will send you moonward. Your spacecraft awaits this critical moment. Your command and service module floats peacefully in low Earth orbit 120 kilometers above the planet's surface. The service module's single AJ-137 engine will soon ignite, producing 97.9 kilonewtons of thrust. This engine burns Aerozine 50, a nitrogen tetroxide hypergolic propellants that ignite on contact, requiring no ignition system. The spacecraft carries 18,410 kilograms of propellant stored in 4 spherical tanks. Every system has been checked and rechecked. Trans-Lunar Injection requires a velocity increase of exactly 3,150 meters per second. This precise delta V will increase your speed by 11,340 kilometers per hour. The burn must occur at exactly the right moment in your orbit when Earth, Moon, and spacecraft align perfectly. Mission Control in Houston monitors every parameter through the Deep Space Network's 364-meter antennas positioned in California, Australia, and Spain. Their voices crackle through your headset, calm and professional. You are go for Trans-Lunar Injection. The words arrive like a gentle wave of approval, carrying the expertise of 400 mission support personnel. Gene Kranz's White Team monitors from Flight Control Room 20 console positions, tracking your trajectory. The engine ignition sequence begins automatic systems, checking fuel pressure, oxidizer flow, electrical connections. In 5 seconds, the burn will commence, committing you to a 3-day journey across 384,400 kilometers of space. Task B2. Ignition. The engine fires with a gentle, sustained push, pressing you firmly into your seat. Unlike the violent acceleration of launch, this feels smooth, controlled, purposeful. The burn will last exactly 5 minutes, 28 seconds, consuming precise amounts of propellant. Outside your window, Earth remains visible, but your velocity climbs steadily toward escape. Velocity 11.2 kilometers per second, the speed needed to break free from Earth's gravitational well. Your breathing remains calm, synchronized with the steady thrust. the service module's propulsion system performs flawlessly. Fuel efficiency measures 96.2%, exceeding predictions just as Neil Armstrong observed during Apollo 11's lunar coast. The spacecraft's 314 separate parameters all show nominal green indicators glowing softly on your control panel. Your trajectory now follows a Hohmann transfer orbit, the most energy-efficient path between Earth and Moon, requiring a total of 5.15 kilometers per second, delta V. Engine shutdown approaches. The engine cuts off with perfect precision. Silence returns, not empty but full, pregnant with potential. You are now on a free return trajectory, the same path Apollo 8 pioneered in December 1968. If your engine never fires again, lunar gravity will catch you, swing you around the moon's far side, and send you safely back to Earth. This elegant orbital ballet, designed by mathematicians and engineers, represents centuries of physics compressed into one graceful arc through space. Frank Borman, James Lovell, and William Anders were the first humans to travel this path. Apollo 8 launched December 21, 1968, from Kennedy Space Center, Pad 39A. Their Saturn V rocket's first stage generated 7.6 million pounds of thrust from 5 F-1 engines, the most powerful machines ever built. They completed 10 lunar orbits over Christmas 1968, reading Genesis to a television audience of 1 billion people. Their courage opened the path you now follow. Breathe slowly, feeling the profound shift in your trajectory. Inhale for 4 counts. 1, 2, 3, 4. Hold gently. Exhale for 6 counts, feeling yourself becoming part of this ancient dance between worlds. Your spacecraft coasts silently, no engine thrust needed, just momentum and gravity guiding you moonward. The journey has truly begun. Your command module, designated by its call sign, measures 5.6 meters tall with a maximum diameter of 3.9 meters. The heat shield at its base, designed for 11 kilometers per second, re-entry velocity spans 3.9 meters across. Inside, your pressurized cabin maintains perfect atmosphere, 760 millimeters of mercury pure oxygen at comfortable temperature. The command module can support 3 crew members for 14 days maximum, though your lunar journey requires only 8 days total. Every system redundant, every backup tested. What's more? The lunar module rides below, attached to the service module, waiting for its moment. This remarkable spacecraft, mass is 15,264 kilograms, divided between ascent stage 4,700 kilograms and descent stage 10,564 kilograms. 2 astronauts will eventually pilot this delicate machine to the lunar surface while you remain in orbit. But for now, it rests dormant, its systems powered down, as you coast through the void between Earth and Moon. Earth begins its gradual recession behind you. The blue marble that filled your window during orbit now appears smaller with each passing hour. Your velocity relative to Earth decreases as gravity pulls against your momentum. You departed orbit at 11.2 kilometers per second, but Earth's gravity slows you steadily. Yet you carry enough momentum to reach the Moon's sphere of influence 66,300 kilometers from lunar center, where Moon's gravity dominates. The mathematics works perfectly. Apollo 10 proved this trajectory in May 1969. Thomas Stafford, John Young, and Eugene Cernan conducted the full dress rehearsal for Apollo 11's landing. Their lunar module descended to 15.6 kilometers above the Moon's surface, close enough to see boulders and craters in sharp detail. Eugene Cernan reported, "We're down among them," Charlie exclaiming at the stark beauty of the lunar highlands. They tested every system except the final landing itself. Your spacecraft's S-band radio system maintains contact with Earth effective up to 400,000 kilometers. Communication signals travel at light speed, taking progressively longer to reach mission control. From Earth orbit, signals traveled 1.3 seconds each way. At lunar distance, the delay increases to 2.6 seconds, creating a 5.2-second gap between question and answer. This lag reminds you of the vast distance opening between you and home. Navigation requires constant attention even on this precisely calculated path. Your crew takes star sightings every 2 to 4 hours using the spacecraft's onboard sextant and telescope. You align crosshairs with specific stars, Rigel, Sirius, Canopus, measuring their positions against Earth or Moon. The guidance computer processes these measurements, calculating your exact position and velocity. James Lovell pioneered these techniques on Apollo 8, manually computing corrections when needed. Mid-course corrections typically require small velocity changes, 10 to 15 meters per second, total across the 3-day journey. These burns, lasting just seconds, adjust your trajectory, maintaining the precise path toward lunar orbit insertion. The service module's reaction control thrusters, clusters of small engines, fire in coordinated patterns. Each thruster produces only 445 newtons, but together they provide precise 3-axis control. Your path remains true. Breathe with the rhythm of your journey. Inhale slowly, feeling yourself crossing invisible boundaries. Hold that breath suspended between worlds. Exhale gently, releasing connection to Earth, embracing the void. Your body floats weightlessly in the cabin. Time flows differently, here measured not in hours, but in distance traveled. Apollo 11 launched July 16, 1969, carrying Neil Armstrong, Buzz Aldrin, and Michael Collins. Their mission fulfilled President Kennedy's goal announced May 25, 1961, to land a man on the Moon and return him safely to Earth. Armstrong and Aldrin would descend in Eagle, while Collins orbited alone in Columbia. Collins later described his solitude during lunar farside passes. "I am alone now, truly alone, and absolutely isolated from any known life." His peaceful acceptance of that isolation mirrors your current journey. The cislunar environment differs profoundly from Earth orbit. Solar wind intensity increases from 400 kilometers per second near Earth to 450 kilometers per second in deep space. Cosmic ray exposure measures 100 times higher than Earth's surface radiation. Your spacecraft passed through the Van Allen radiation belts during departure, spending 30 to 60 minutes crossing these dangerous zones. But your aluminum hull and careful trajectory planning kept exposure within safe limits. Temperature extremes test your spacecraft's thermal control systems. In Earth's shadow, temperatures plunge to minus 156 degrees Celsius. In direct sunlight, they soar to plus 121 degrees Celsius. Your spacecraft slowly rotates in barbecue mode, distributing solar heating evenly across all surfaces. This gentle rotation, one revolution every 20 minutes, prevents any side from overheating or freezing. Micrometeorite impacts remain a constant concern, though statistically rare. Cislunar space contains approximately 10 to the negative 17th to 10 to the negative 16th kilograms per square meter per second of tiny particles. Your spacecraft's hull can withstand impacts from particles smaller than 1 millimeter. Larger objects are tracked by ground-based radar, giving advance warning of potential collisions. The vast emptiness of space protects you. Apollo 12 launched November 14, 1969, carrying Charles Conrad, Alan Bean, and Richard Gordon. Their mission achieved the first precision landing, touching down within 200 meters of Surveyor 3 probe. Conrad's skill as a pilot enabled this accuracy despite computer guidance failures during final descent. They proved that astronauts could land anywhere on the Moon with confidence. Their journey followed the same path you now travel. Earth continues shrinking behind you, now appearing as a bright blue star against infinite darkness. The planet that dominated your view during orbit becomes one point among thousands. Clouds swirl across its surface, weather systems visible as white spirals. At this distance, 300,000 kilometers, Earth appears smaller than your thumb held at arm's length. Yet it contains everything you've ever known, everyone you've ever loved. Your breathing slows, naturally matching the peaceful rhythm of spacecraft systems. Inhale gently, feeling life support, maintaining perfect atmosphere. Oxygen flows smoothly, carbon dioxide scrubbed away by lithium hydroxide canisters. Exhale softly, your breath becoming part of the recycled air. Temperature remains precisely controlled. Every need anticipated, every system functioning. The moon grows imperceptibly larger ahead, still too far to show surface details. Our natural satellite orbits Earth at 1.023 kilometers per second, completing one revolution every 27.3 days. The moon formed 4.5 billion years ago, when a Mars-sized object collided with early Earth. Debris from that impact coalesced into the moon, creating Earth's eternal companion. You approach this ancient world born of cosmic violence, now peaceful and serene. Apollo 13 launched April 11, 1970, carrying James Lovell, John Swigert, and Fred Hayes. Their mission ended in crisis when an oxygen tank exploded 55 hours into flight. The crew abandoned the crippled service module, using the lunar module as a lifeboat. They swung around the moon on a free return trajectory, the same path you follow returning safely April 17th. Gene Kranz's famous declaration, "Failure is not an option-guided mission control through the crisis." Your spacecraft coasts silently through the void. No engine thrust, just momentum carrying you forward. Gravity's invisible hand gradually slows your Earth relative velocity, while Moon's gravity gently accelerates you. At the Lagrange point, 1,326,000 kilometers from Earth, gravitational forces balance perfectly. You crossed this invisible boundary hours ago. Stars surround you in every direction, unblinking points of ancient light. No atmospheric twinkling here, just steady, constant illumination from distant suns. Some stars you observe no longer exist, their light traveling centuries to reach your eyes. You witness the past and present simultaneously floating between Earth and Moon, between what was and what will be. Time itself feels fluid here. Breathe deeply, feeling profound peace. Your journey continues. Day one of your 3-day journey progresses smoothly, all systems nominal. Mission Control reports your trajectory within 0.5 kilometers of planned path. This precision results from decades of orbital mechanics calculations, beginning with Newton's laws published 1687. Every Apollo mission benefited from this accumulated knowledge, mathematics transformed into reality. Your spacecraft embodies centuries of human understanding. the Deep Space Network maintains constant communication. When California's Goldstone antenna drops below the horizon, Australia's Honeysuckle Creek takes over. As Australia loses signal, Spain's Madrid station acquires your spacecraft. This global network ensures you never lose contact with Earth. Voices from home reach across the void. Your command module pilot monitors life support systems continuously. Oxygen partial pressure measures 160 millimeters of mercury, perfect for human respiration. Cabin temperature holds steady at 21 degrees Celsius. Humidity levels remain comfortable, preventing condensation on windows and instruments. Every parameter green, every system functioning flawlessly. The Surveyor program prepared this path. 7 robotic landers touched down between 1966 and 1968. They tested lunar soil, bearing strength, analyzed surface composition, photographed potential landing sites. Surveyor 3 landed April 20th, 1967 in Oceanus Procellarum. Apollo 12 astronauts would visit it 30 months later, retrieving its camera. Earth's gravity weakens with every kilometer traveled. At Earth's surface, gravity measures 9.8 meters per second squared. At lunar distance, it decreases to 3.69 meters per second squared. Yet even this diminished pull influences your trajectory. You exist in gravitational balance between two worlds. The Soviet Union's lunar program competed for Lunar First. Luna 2 impacted the Moon. September 14, 1959, first human-made object to reach another world. Luna 3 photographed the far side, October 7, 1959, revealing what no human had ever seen. These robotic pioneers mapped the path for human exploration. Competition drove innovation on both sides. Breathe slowly, synchronizing with your spacecraft's gentle rhythm. Inhale, feeling life support systems working perfectly. Exhale, releasing any remaining tension. Your body floats weightlessly, supported by nothing, held by everything. The Moon's sphere of influence extends 66,300 kilometers from its center. When you cross this invisible boundary, lunar gravity dominates Earth's pull. Your spacecraft begins falling toward the Moon, accelerating gradually. This transition happens smoothly. No sudden change, just gentle shift in gravitational balance. The Moon claims you. Navigation star sightings continue every few hours. Your crew aims the sextant at Rigel, measuring its angle relative to Earth's limb. The computer processes these measurements, updating position and velocity estimates. Actual position matches predicted within acceptable margins. No mid-course correction needed this cycle. William Anders captured the famous Earthrise photograph December 24, 1968. Using a Hasselblad 500 EL camera with 250mm lens and Kodak Ektachrome film, he photographed Earth rising over lunar horizon. Frank Borman exclaimed, "Oh my God, look at that picture over there, Earth coming up." That image transformed human consciousness, showing our planet's fragility and beauty. Perspective shifts everything. Day 2 arrives measured by Mission Control's clock. In space, sunrise and sunset lose meaning without atmosphere to scatter light. The sun remains constant, unblinking its light, harsh and direct. Only Earth's shadow provided darkness during departure. Now only infinite void surrounds you. Your spacecraft continues its barbecue roll, one revolution every 20 minutes. This passive thermal control distributes solar heating evenly. Without rotation, one side would bake while the other froze. The technique works perfectly, requiring no active cooling or heating. Simple solutions often prove best. Ranger spacecraft preceded Apollo missions. Rangers 7, 8, and 9 crashed into the Moon in 1964 and 1965. But before impact, they transmitted thousands of detailed photographs. These images revealed lunar surface features down to meter scale. Apollo planners studied every photograph, selecting landing sites carefully. The Moon grows visibly larger now. Surface features begin emerging from the grey disk. Dark Maria seas of ancient lava flows contrast with bright highlands. Impact craters dot the surface, recording 4 billion years of cosmic bombardment. Lunar geology tells Earth's early history. Buzz Aldrin took private communion during Apollo 11's lunar approach. He read John 15:5, "Apart from me, you can do nothing." This spiritual moment reminded him of powers beyond human achievement. Many astronauts reported profound religious or philosophical experiences. Space humbles and elevates simultaneously. Your velocity relative to Earth decreases, while Moon relative velocity increases. Gravitational dance between two bodies creates this elegant exchange. You slow in one frame, speed up in another. Reference frames matter in orbital mechanics. Einstein understood this deeply. Communication delays lengthen as distance increases. Mission Control asks question 2.6 seconds all pass before you hear it. You respond 2.6 seconds pass before Houston hears. Conversations become deliberate, measured, careful. patience becomes essential. John Young piloted Apollo 10's command module during lunar orbit. He monitored 314 separate spacecraft parameters continuously. Every gauge, every indicator required attention and interpretation. His vigilance ensured mission success. Astronauts were test pilots, first explorers, second. Breathe gently with the flow of time and distance. Inhale slowly, feeling yourself approach the moon. Hold that breath, suspended between worlds. Exhale softly, releasing into this journey. Tidal forces remain negligible on your small spacecraft. But across the moon's diameter, they create 2-meter differential. This gradient locked the moon's rotation to its orbit. One face always points toward Earth, the far side, forever hidden, until Luna 3 photographed it. Gravity shapes everything, given enough time. The moon's average distance from Earth measures 384,400 kilometers. But lunar orbit is elliptical, varying from 356,500 to 406,700 kilometers. Currently, the moon sits near average distance. Your trajectory accounted for this precise positioning. Timing matters in orbital mechanics. Neil Armstrong monitored fuel consumption during Apollo 11's approach. Service module efficiency measured 96.2% better than predicted. Extra fuel provided margin for emergencies or extended operations. Engineers designed conservatively. Astronauts appreciated that caution. Redundancy saves lives. Day 3 begins your final approach to lunar orbit. The moon dominates your forward view, now clearly showing its scarred surface. Mare Tranquillitatis, Sea of Tranquility, appears as dark region. This is where Apollo 11 would land, July 20th, 1969. History waits in that ancient lava plain. Craters become individually visible. Tycho's brilliant rays streak across the southern highlands. Copernicus sits in western Maria, its terraced walls and central peaks distinct. Each crater tells a story of cosmic impact. The moon remembers what Earth's atmosphere erased. Alan Bean later became a painter, capturing his lunar experiences in art. He described lunar light as like a silver spotlight on black velvet. No atmosphere softens the contrast between light and shadow. This stark beauty cannot be photographed, only witnessed. Some experiences transcend documentation. Tahiti. Your spacecraft accelerates as lunar gravity strengthens. Without braking, you would swing around the far side and return to Earth. The free return trajectory provides built-in safety. But to enter orbit, you must fire the engine at precisely the right moment. Lunar orbit insertion approaches. Mission Control confirms trajectory one final time. All parameters, nominal timing, perfect velocity correct. You are go for lunar orbit insertion. The burn will occur behind the moon during farside pass. For 30 minutes, you will lose all contact with the Earth. The moon's far side approaches. This hemisphere remained unknown until 1959, forever facing away from Earth. Fewer Maria more heavily cratered the far side shows moon's violent past. Radio signals cannot penetrate the moon's bulk. You will be truly alone. Dao. Michael Collins described his solitude during Apollo 11's far-side passes. I am alone now, truly alone, absolutely isolated from any known life. He circled the moon while Armstrong and Aldrin walked its surface. His peaceful acceptance of isolation reflected deep inner strength. Solitude brings clarity. Breathe deeply as you approach this moment. Inhale feeling, anticipation, and calm combined. Exhale releasing into trust and preparation. Your training, your spacecraft, your crew all ready. Loss of signal occurs as Moon's bulk blocks Earth. Radio silence descends, complete and absolute. No contact with mission control, no communication with home. You float in perfect isolation, 384,000 kilometers from Earth. The universe narrows to your spacecraft and the Moon. The far side terrain passes below alien and ancient. Craters overlap craters' geological violence, frozen in stone. This landscape formed 4 billion years ago and barely changed since. No erosion, no weather, just cosmic impacts and time. The Moon preserves Earth's early history. Lunar orbit insertion burn approaches. The service module engine must fire for exactly 4 minutes, 17 seconds. This will reduce your velocity, capturing you into lunar orbit. Miss this window and you return to Earth without achieving orbit. Everything depends on this moment. Engine ignition. The familiar push returns, pressing you gently into your seat. Propellant flows, perfectly thrust builds to specification. Your velocity decreases as the burn progresses. Outside the far side, landscape continues scrolling past. The engine performs flawlessly. Four minutes, 17 seconds, exactly. Engine shut down. Silence returns. You are captured in lunar orbit. 300 kilometers above the ancient surface. The spacecraft continues around the far side. Gradually, the Terminator approaches the line between lunar day and night. Shadows lengthen across crater floors. Peaks catch sunlight while valleys sink into darkness. Light and shadow create dramatic relief. Acquisition of signal approaches. Soon Earth will rise above the lunar horizon. Radio contact will resume. Mission Control waits anxiously for your signal. Did the burn succeed? Earth appears over the lunar horizon. The blue marble rises above grey desolation. Your radio crackles to life. Houston, this is your call sign. We are in lunar orbit. Cheers echo across space from Mission Control. Breathe deeply, feeling accomplishment and peace. Inhale the satisfaction of arrival. Exhale, releasing the tension of the journey. You have crossed the void between worlds. Your orbit takes 2 hours to complete. 60 minutes over the near side, 60 minutes over the far side. Each orbit alternates between contact and silence. You circle the moon every 2 hours. Orbital mechanics in perfect balance. Mare Tranquillitatis passes below. On July 20th, 1969, Eagle descended here. Neil Armstrong took manual control, avoiding boulder field. With only 20 seconds fuel remaining, they landed. That's one small step for man. The landing site appears unremarkable from orbit. Just another stretch of grey regolith. But it marks humanity's first footsteps on another world. History concentrated in one small area. The Eagle has landed. Oceanus Procellarum slides into view. Apollo 12 landed here, November 19, 1969. Charles Conrad's precision piloting set them down near Surveyor 3. They walked to the probe, retrieved its camera. Robots and humans together exploring. Framauro Highlands appear rugged and complex. Apollo 13 should have landed here. Instead, they swung around the moon, returning safely home. Apollo 14 completed their mission January 1971. Every failure taught valuable lessons. Your orbit settles into peaceful rhythm. The moon rotates slowly beneath you. Each 2-hour circuit reveals the same ancient landscape. Yet the lighting constantly changes. Shadows shift, craters appear different. Earthrise occurs every orbit. Our planet appears above the lunar horizon, blue and white against black void. Life and warmth contrasting with lunar desolation. Home, visible but unreachable. Chatin. The moon's surface shows no erosion. Craters from billions of years ago remain pristine. Footprints left in 1969 will last millions of years. No wind, no water, no weathering. Time moves differently here. Breathe slowly with orbital rhythm. Inhale over the near side. Exhale over the far side. Your body synchronized with lunar orbit. Stars shine brilliantly above. No atmosphere dims their light. Constellations appear as they truly are. The moon's thin exosphere provides no interference. Universe visible in perfect clarity. Your spacecraft maintains altitude effortlessly. The moon's gravity holds you in stable orbit. No atmospheric drag to decay your path. You could orbit for decades without adjustment. Orbital mechanics proven perfectly. The Moon formed 4.5 billion years ago. A Mars-sized body struck early Earth. Debris coalesced into our natural satellite. That violent birth gave Earth its moon. Destruction created beauty. Lunar gravity measures 1.62 meters per second squared, 1/6 of Earth's surface gravity. Astronauts bounced in slow motion across the surface. Each step became a gentle leap. Movement transformed by reduced gravity. The Moon's diameter spans 3,474 kilometers, about 1/4 Earth's diameter. Its mass equals 1.2% of Earth's mass. Yet it dominates our night sky. Proximity creates apparent size. Your orbit carries you peacefully around. Each circuit reveals familiar terrain. Mare Imbrium, Mare Serenitatis Mare Crisium. Seas that never held water. Names from ancient astronomers. Mountains rise from the lunar plains. The Apennine Range stretches 600 kilometers. Peaks reach 5,000 meters high. Formed by ancient impacts, not tectonic forces. Every feature tells impact history. D. Breathe deeply, feeling peace and wonder. Inhale lunar orbit's serenity. Exhale Earth's distant concerns. You float in eternal present. Reels snake across Maria floors. Ancient lava channels now frozen. Some stretch hundreds of kilometers. Volcanic activity ceased billions of years ago. The moon died geologically. Tycho crater dominates the southern highlands. Its rays extend 1,500 kilometers. Impact ejecta spread across the moon. This crater formed 100 million years ago. Recent by lunar standards. Your orbital velocity measures 1.63 kilometers per second. This speed maintains your 300-kilometer altitude. Faster, and you would escape lunar orbit. Slower, and you would spiral downward. Perfect balance achieved. Each orbit takes you over light and shadow. Craters in sunlight show every detail. Craters in darkness, invisible and mysterious. The Terminator constantly moves. Light chases shadow across the moon. The moon's far side remains hidden from Earth. Tidal locking keeps one face always toward us. But you see both sides, each orbit. privileged perspective few humans share. Explorer among explorers. Breathe gently with the moon below. Inhale ancient lunar dust. Exhale into cosmic silence. Your orbit eternal and peaceful. Earth rises again over the horizon. Blue marble against grey desolation. Home distant but visible. Connection maintained across void. Never truly alone. Your spacecraft systems hum quietly. Life support maintains perfect atmosphere. Temperature controlled, humidity balanced. Every need met automatically. Technology supporting life. The lunar surface passes endlessly below. Grey regolith covering everything. Billions of years of impacts. History written in stone. Time made visible. Stars wheel overhead, unchanging. Constellations, ancient patterns. Same stars, ancient astronomers observed. But clearer, brighter. Space reveals truth. breathing slows naturally. Each breath deeper, more peaceful. Orbital rhythm soothing. The moon cradles you gently. Gravity's embrace, holding you in orbit. Safe and secure. Protected by physics. Darkness and light alternate. Each orbit brings both. Day and night compressed. Time flowing differently. Eternal present. Your body completely relaxed, weightless and free, floating peacefully. No tension remaining. Perfect rest. The moon turns slowly below. Ancient surface unchanging. Craters, mountains, Maria. Familiar now. Your moon. Del. Earth watches from distance, blue and beautiful, home among stars, always visible, never forgotten. Breathe softly now, barely perceptible, life-sustaining itself, effortless flow. Your orbit continues, path unchanging, around the moon, forever circling. Eternal dance. Consciousness fading gently into peaceful sleep. Dreams approaching. Soft transition into rest. Sleep now. Space traveler in lunar orbit. Safe and peaceful. Your path secure. Orbit stable. Forever circling. The Moon. Gravity holds you. Gently. Peacefully. Safe. Earth distant, but present, always watching. Home. Stars shine eternally. Ancient light, peaceful. You rest in orbit, floating free, dreaming. Deep sleep. Lunar embrace. cosmic peace. Rest now, completely. Sleep. Among stars, forever safe. Sleep peacefully.